So let's look at the chapter 15 through the chapter 20, Introduction to MATLAB. So this chapter we only focus on the MATLAB. What is MATLAB? MATLAB is a kind of programming software, but it's more toward some mathematical equation solver and some optimization program solver. So it's more designed, more engineering aspect, not just the C or C++. This program is more focused on to find the solution from the very complicated equations. But there are many aspects why we need to use MATLAB in engineering programs. Let's look at them generally. This software, this program was developed by me when I was in University of Michigan. My supervisor asked me to visualize when we change the seat height, then how their seating position for female and the male drivers, how their position is going to be changed. So I developed a statistical model to predict the joint locations, but this program is especially useful to visualize what is the predictions result by the statistical model once we change the input variables. So if we change some stature or seating height for female and male separately, then how their eye positions is, where is the eye location is going to be, and where is the T12 arrow joint location is going to be. So this is a useful tool to visualize and to compare what is the difference between female and male, things like that. So this is developed by MATLAB. MATLAB is a very useful tool, not just the calculation but also visualizations. Today we have 3 learning goals. The first one is know data types in MATLAB. There are numerical type or character type or string types, so there is a types. The second one is know basic built-in function in MATLAB. Okay, there is a built-in functions. We cannot look at all the functions, but let's look at the function that is frequently used in programming. And the last one is how to create 2D or 3D plot using MATLAB. Okay, so let's look at the data type. Why we need to learn programming? I'm not talking about the MATLAB itself. I'm talking about programming, the overall the programming. Why we need to learn the programming? Have you ever thought about this before as an engineer? Okay, it's hard to say because it's too general questions, so there should be many answers possible. But what I'm thinking is, if you know and how to do the programming, then you can work faster than who don't know the programming. Okay, engineer, as I mentioned, engineer is a problem solver. Okay, problem solver. So how to solve the problem? Maybe you can apply some mathematical skills, statistics skill, or physics. That is the basic knowledge, right? So you know the basic knowledge, but if you know the programming skill, then it can boost up your ability to solve the problems very efficiently and accurately. Okay, not just C or C++, C#, MATLAB, Java, Python. Those languages are very useful to iteratively generate some certain formula, certain equation, or very complex, highly degree nonlinear program solution. The program can find easily. So not just having the basic knowledge, if you have programming skill, that would be very beneficial when you graduate and when you go to the company. You can become a very important guy in that company. Okay, so MATLAB is a kind of a two-word. The matrix laboratory is a combined two words and take some several word in front of word, right? MATLAB, okay? Matrix laboratory. What is matrix? The matrix, as you can see here, this is the matrix. Matrix has a size m by n, okay? M is a number of row and n is a number of columns, so m by n. So it's MathWorks developers, developed by MathWorks. It released in 1984. It's almost it's the same age with me. And this is very useful and highly functional tool language for technical computing and plotting. And this is not free. It's very expensive software. I'm not quite sure how much the license of full version, but it's very expensive. But our school invest a lot of money to get a number of copy of the licenses. But so don't worry too much about. You don't need to buy this software. The school has the license. So here, for example, there are very complicated trigonometry equations using the MATLAB. We can create a figure, create some 3D images that can represent these equations. So if you put some x and y values, then we can find z according to this equation. This is the result. This is the result. Alright, it looks very complicated, very beautiful piece of something that it looks like a flower. But anyway, this equation can be expressed like these figures using MATLAB. Alright? So size of the matrix, as I said, it's m by n matrix. So question, what is the size of the right hand side this matrix? Yes, that is 3 by 3. How about this one? It's a 2 by 3 matrix. So 2 means there are 2 rows, and 3 means there are 3 columns. Okay, n is, let's say n is the number of independent variables. So you can always think about the column should represent the independent variable, and the row is dependent variables. So for example, what we learned last time, we used the US Army anthropometric data. If you think about that data, the column always indicate what is the stature, weight, and some sitting height. There are dimensions, right? That is independent variable. Whereas dependent variable is a measurement for a number of different size of people. All right. Okay. So can MATLAB express a multiple size matrix such as m by n by k? It's three-dimensional matrix. Sure, we can make it. So this is an example. This is a beautiful images here, and with various color images. Here we can circle area. We have a circle area here, so we can see this area is expressed as a number. We call this is RGB matrix. So R contains 0 to 1. So 1 is very red, okay, very red. And G also has the value from 0 to 1, and B, blue, has value from 0 to 1. So within this range, there are a number of values. It's possible. So if we took this area, there are colors like sky color. Then we can see how the RGB data is going to be in each pixel. Okay. So you can see this is the 3D matrix, 1D, 2D, 3D, right? So here this is the image surface, and then the image, each pixel has the RGB data, the more depth data, right? So this is 3D data. So I mean, this is very interesting topic. We can change a certain number of the red value to the some other low level value. I mean, it's possible. So we can change the color of the images if we put some different number on RGB data. This is image processing, and we can take a certain image area that contains specific RGB data values. That's also one of the image processing techniques. So there are many applications, such as in medical application, there is a lot of CT images. In CT images, we can find a specific color information. Let's say that is some kind of brain tumor. Okay, brain tumor. Okay, we want to find the brain tumor from the CT images that contains a specific color information, right? So that we can, using the programming skill, and find whether the tumor exists or not. Okay, that is the image processing area. We can always use in medical applications. Alright, this is the MATLAB interface. Interface wise, the left side there is current folder. This is important. The command window. So we can do some action. Okay, we can give some command in here, command window, and we can also see the result. We can also see the result from this command window. And the workspace contains which variable you defined, and which value are contained in the variables. So you can write your MATLAB code here, command window. So let's practice a little bit. Let's put 1/3 size matrix, and the value should be 1, 2, 3 into a variable a. So in this case, we can just simply say a equals bracket 1, 2, 3 and close the bracket. That means variable a has 1/3 matrix. The value is 1, 2, 3. Alright, and we want to check the first element in variable a. Then we can just simply say a parentheses 1. So 1 is the first element. So if we want to see the second element, then we can say a parentheses 2. Here the a1, the first element of the a matrix is 1, right? So that's why it shows 1. Let's put a 3/3 size matrix into variable c. Okay, it's easy. So c equals bracket 1, 2, 3. This is a semicolon, right? It's change the line. And 4, 5, 6, 3 data, change the line, 7, 8, 9. So this c, variable c contains 9 elements and the 3/3 matrix, and the value contains 1 to 9. Okay. So question is, what is the answer c parentheses 2, 2 parentheses close? What is the answer? Well, in this case, the answer is 5, right? So this is index, right? So second row and the second column. First row, second row, third row. First column, second column. So this 5, right? And how about 3, 1? 3, 1. So this is the row and the column, right? So 1, 2, 3, and the first column, that is the 7. Okay, so answer is 7. And the last question is, what is the c column, 1? So this column means all the elements. The column 1 is first column. So here, the first column, the order element, so we can say the result is 1, 4, 7. Okay? Alright, we can also do the calculations. So A contains 1, 2, 3. Here, this is the result. And the variable B contains 4, 5, 6. Okay, here is the result. And both are 1 by 3 size of matrix. Okay, 1 by 3 because there are only 1 row and 3 columns. And then what is the answer? A1 plus B2. Right, the answer is 6 because the A1 is, we have 3 data. The first element of A is 1 and we have 3 data for B, but the second element of B is 5, right? So 1 plus 5 is equals to 6, right? We can also use some other operator, not just plus, or we can use minus, multiply, divided, square root, things like that. So as you can see, the MATLAB always, you can see always the MATLAB code has a certain formula, and certain format. Variable equals data. So this data goes into this variable. Okay, but there is a naming rule for variables. The first one is, so the variable name of the variable consists only letters, numbers, and underscore character, not middle score character. Okay, and the second rule is only begin with the alphabetic letters, not number. Okay, and not special characters. And the third one is the name cannot be longer than the 63 figures, the 63 characters. And in MATLAB, it's case sensitive. So for example, if you use a frog, the upper character F and the lower character F frog is different. Both are different. Okay, it's case sensitive. And the last one is, even though we cannot build any different kind of names for variables, but we should be avoid the same word as built-in functions. So there are many built-in functions in MATLAB, but you cannot use that name as your variables because it's already existed in the MATLAB. Okay, so that's it. And one thing that I want to emphasize is that, so if you make thousands of lines of programming code, then you can easily easily forget where is the variable and what was the variable's names. So think about when your program becoming complexity, you have to put your variable's name more specifically. Alright, so try to use the specific word for your variable so that you can find out or you can remember the name very quickly and very intuitively. It logically makes sense. Okay. The question, so we have 1, 2, 3, 4, 5, 6 candidates here, but some of them can be a variable name, but some word cannot be the variable name in MATLAB. So which one are valid as a MATLAB variables? So A, is it okay? Okay, how about B? We have a math 6, I think it's okay. How about C? It starts with a number. As I said, the variable should be start with the alphabetic letters, right? And then how about D? D contains a special character, so it cannot be used as a variable name in MATLAB. How about E? My file, it's not underbar, right? If it is underbar, it makes sense, but middle bar, no. How about the last one, reactor yield? It used the upper character here, but as I said, MATLAB is case sensitive for upper and lower case, so I think it works. So the answer is A, B, and F. Now we learned about what is the naming rule for the variable. Let's look at the data. So there are many different types. Numerical value, as I said, it can contain any numerical value, 1 or 3.5 or 100.23. Any numerical value is fine. And also the MATLAB can deal with imaginary numbers. Okay. So for example, A equals 12i here. Okay. And also the MATLAB can deal with matrix type. So this is the matrix, right? As I said, this is the size of this matrix is 1 by 3, and the value is 1, 2, 3, and the zeros is actual built-in function in MATLAB. It can create 3 by 3 size of 0 matrix. The matrix contains the 0 values. How about ones? Ones that create 5 by 5 matrix that contains only value 1s. 1. Alright. Here is a little interesting point. So MATLAB also can treat character type. Okay, so this is the variable, right? Variable contains the T, but here you can see the quotation mark here. Single quotation mark, and the B equals A, the single quotation mark. So that means this variable contains the alphabet character T, and or the B contains A. But here you can see C equals 1, and there is a single quotation mark here, which means the C, variable C, contains character 1, not numerical value 1. You know what I'm saying? So this C contains character, not numerical values. Okay. And also the MATLAB can handle string type data. So for example, the variable A contains I love TAMUCC. Okay, there is a single quotation mark here. But be careful, the MATLAB in terms of the matrix cannot contain the mixed data types, such as this one is a numeric value, T is character, and the jargon is, it's a string type. So we cannot mix the type of data. So it should be number only, or it should be character only, right? There is no mixed types. Okay. All right. So here we have some example. A contains I love you, and B contains TAMUCC. What is A 1, 1? So here you can see A contains a string data type, and this string data has a size. Okay, and this is 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is actually 1 by 10 size matrix. Okay, because each character contains one space. Okay, so 1, 1 is, the answer is just I. So 1 is here 1 is the first row and the first column, right? So first row, first column is here I. And also we can combine two string data type. You can use bracket here, A space B bracket here, and the answer is I love you TAMUCC. But here there is no space between two words. Okay. But if we put one space and the quotation mark, and actually this is one character, the space, blank space. So the answer is I love you, one space, and TAMUCC. Okay. What is the size of variable B here? Size of B here is 1 by 1, 2, 3, 4, 5, 6. So 1 by 6. The answer, we can also say size B is always the 1, 6. So that means there are only one row and 6 columns. Alright, the next concept is a little bit complicated concept. We can change from number to character, character to numbers. So it's a very useful tool, function. You can understand this is basically the built-in function in MATLAB. So num to string, string to num. So num to string, what is the meaning? Change the number to string type. String to num, change the string to number type. So let's look at the example. So A contains 1. This 1 is, there is a single quotation mark, so it's character. We want to change this character to the numeric value, then it's just simply say string to num, parentheses, and A, then this function automatically change the values in here to the numeric value. Okay, this is the number, this is integer. But here, this one is character. The opposite case, the C contains the number 2, which is integer, right? And we want to change it to the string type, so number to string 2 or C, or we can change it. Then C contains 2 as a character. Okay, this is a string type. Also, the MATLAB can handle the E notation. Let's put the variable name E notations and equals 1E10, but it means 1 by 10 to the 10th power, right? Square root, so 25, we can root 25, the answer is 5, and the log 1 is natural log, so I think the answer is 0, right? And the common log is the base 10. In this case, the answer is 1. And here we can also use some statistics. If the variable A contains this 7 data and the mean A, here the answer is 4. Okay. The next concept is how to round the values. There are 4 different types of round functions. So 3.5, we have this number, round 3.5. Round means round to the nearest integers. So nearest integer here is 4. Say round toward positive infinite. Round toward positive infinite. That is number 4. Floor, round toward negative infinite. So round toward negative infinite. That is 3, right? The fix, round toward 0. So this value round toward 0. So the answer is 3. Trigonometry. So here you can see the sine D, parentheses, cosine D, tangent D, and you may know about arctangent and arccosine, arcsine. So let's look at the sine D 90 degree. So what is the 90 degree in sine functions? So that is the answer 1, right? And we can also change it. What is arcsine D1? So you can change it to, you can say the degree. So the answer is 90. Okay. So MATLAB can handle many different type of data types and trigonometry, statistics, metrics. So it's very powerful tool to handle many different types of the data. Linear, non-linear model, we can use the polyfit function. I want to introduce how the MATLAB is a very powerful tool to estimate the data. So here we have x and y. The x is weight and y is stature data. We have 9 data points set here. We can use polyfit function, which is built-in function in MATLAB. The polyfit stands for polynomial curve fitting. Okay, and the x, y, n. This is a kind of some grammar how we use the polyfit function. So x is independent variable, y is dependent variable, and n is the degree of order of your mothers. Okay, so x and y and b. X contains 49 here, 49, 60, and 54. So there are semicolon because the semicolon changed the line, right? And y contains 163, 166, 162, things like that. So we have 9 x data and 9 data for y data. Okay, so we used polyfit function here and the parentheses x comma y comma 1. So this one is we are going to make a mother for one single variable. Okay, so that contains to the that goes into the b. Okay, so variable b, if we learn this code, then variable b has 0.1270 and 157.0436. So what is mean? What is the meaning of this? So first column, actually the B has a 1 by 2 matrix, right? This is 1 and 2. So it's 1 by 2 matrix. And the first column means this is a slope. Okay? Slope of the mother, and this is the intercept. So we can express the answer. This is y equals 0.127x plus 157.0436. So basically this one was our midterm exam 2 questions, right? And we can build a model using these polyfit functions. Here's the thing though, if we increase the number, the last column here as a 2, then what is the answer for C? The C contains 3 variables. So first one is actually the coefficient of x square term, and this is coefficient for x, just x term, and this is intercept. So we can express like this. Okay, here. So we can always increase the number of the polyfit function here, 3, 2, or even 100, right? But please be careful when you increase the degree of your models. It's going to be more complex model than simpler model. So you have to choose accuracy and the simple one. Which one is your target? Okay, so that's it. Well, so we learned some if statement, how to use if statement in the Microsoft Excel. MATLAB also has if statement. So the syntax is if there is some conditions. So we can say expressions. This expression, if it is true, then statement 1 will be show up, and this is a closed if statement. The another one is if there is a statement. So let's say conditions. These conditions fulfill, satisfied, then statement 1 will show up. But if it is not satisfied, maybe this is a false, then goes to the else. Okay, so statement 2 will show up. And the third one, if there is a statement express 1, if this expressment is true, then statement 1 will show up. But if it's not true, then goes to the else if. There is another if. There is expression, if it is true, then statement 2 will show up. But if it is not true, then goes to the else. Okay? But if it is true, then it did not go to the else. Okay? Then it stopped here. That's it. And break these equations. But anyway, this is not true, then goes to here because it's else. Statement 3 will show up. And this is the close of this if statement. Okay? So let's look at question. What is an output of this code? You have 1 minute. Alright, let's look at together. We have two variables, and R contains 3 and C contains 4. So let's look at here. If R is greater than C, is it true? No, it's not true. So because 3 is smaller than 4, right? So it did not express this one. It goes to the here. Else if there is another if, so does R is equals to C? No, right? It's 3 and 4. So this statement will be ignored and go to here, else then display this. But here you can see num to string. What is this? This is the built-in function in MATLAB. It changed the data type from number to string, right? So R actually has a number here. So 3 changed to the character 3. Okay, is smaller than, there's another num to string C, so 4, right? So 3 is smaller than 4. That is the answer. 3 is smaller than 4. And let's look at another one, is a loop statement. There are two loop statements. We can use for and we can use while. Let's look at the for. So for is until this index reach to the values, this statement will show up repeatedly. Okay, the program will activate this statement repeatedly. Okay, so this is the syntax. Let's look at the more detail. So for I equals 1 column 8. So this means from 1 to 8. If I goes from 1 to 8 with 1 increment. Oh, sorry, there is a typo here. It's from 1 to 8 with 1 increment. Okay, that means 1, 2, 3, 4, 5, 6, 7, 8. So it means this for loop will activate 8 times. Okay, display I love time UCC. So the answer is these sentences, this string character, this string type data will show up, will be displayed 8 times, because when I goes 1, it shows up. When I increase 2 as a 2, it shows up, and 3 shows up, and 4 shows up. So 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So for example, the first sentence, I love time UCC, this one, when I equals 1, and the second one is when I equals 2. So there is an increment with 1 increment, okay, from I goes 1 to 8. Here's another example. I equals 1 column, 2 column, and 16. So what is the meaning of this? This is from 1 to 16 with 2 increment. Here we have a middle value. So this is the starting point and this is ending point. You probably noticed that. And the middle value here is indicating the increment. Okay. But how about the previous one? There is no values. There is only 2 values, right? So MATLAB automatically think about this is 1. Okay, this is starting point and this is end point with 1 increment. That is default. Okay. But how about here? We change the increment as a 2. So from 1 to 16 with 2 increment step. So that means 1, 3, 5. So with 2 increment, right? 7, 9, 11, 13, 15. So be careful, there is no 16, because if we increase 15 to 17, but you have to make sure that the ending point is 16, not 17, right? So it skipped. So there are only 8 times. The display I love time UCC will show you 8 times. When I equals 1, when I equals 3, when I equals 5, when I equals 7. Things like that. It's very easy concept. Alright, now we are going to look at some plotting. Okay, this is a totally new concept. Okay, how to make a plot using MATLAB. Okay, so here we have data, and B, as I said, the polyfit function is generating some statistical models to predict the y value using the x value, right? Here we can also use a plot. This one is creating plot. Okay, plot. This is a basic built-in function of MATLAB. X, comma, y, comma, quotation mark here, and O. So this is showing like this. So the x-axis shows the weight, right? This is the weight, so x-axis, and the y-axis shows the stature, right? Stature, and this one is x comma y, x comma y, x comma y, x comma y. So we have 9 data set as a pair, right? So x comma y, and the expression, in the plot, we used a circle. Okay, this is the circle, and the color inside the circle, there is a transparency, but the circle, the color is the default is blue actually. So that's why the blue circle shows up. The 9 blue circle shows up. How about if we want to change the face color and edge color? So let's say we set the marker face color, comma, quotation mark, red. Okay, and the marker edge color, quotation mark, black. What is the meaning of this? So there is a circle. The face color should be red, and the edge color will be changed from blue to black. Okay, like this. So face color is red, and the edge color is black. Okay, we can also put the title, X label and Y label and legend. Okay, so here what we learned so far: plot X comma Y comma O, and we can change the color of marker face and the marker edge. This is the result, right? And how about if we put some title parentheses, weight versus stature, and equals 9. X label, Y label, and the legend, US Army, we can put it like this. Then you can see the changes. There are title here, and Y-axis label, and X-axis label here. Okay, and then we have a legend here, US Army. And also we can set the range of X and Y-axis. So let's set the X-axis. So axis, this is the built-in function in MATLAB. So A-axis, parentheses, bracket, 30, 90. This is the range of the minimum and the maximum of the X value, and this is the minimum and the maximum of Y value. So 150 and 190. And then we execute this code. Then you can see the range of the value has been changed. So this x-axis minimum is 30 to 90, and 150 to 190 for y values. Okay, and we want to add a trend line. So here, this polyfit function make a statistical model, and this one indicates there are only first order of this the models. So here we already learned about this concept. We get a y equal 0.1 to x plus 157.0436. This is the statistical model. So whatever we put some value x, then this model will tell you what is the y value according to corresponding the x values, right? So let's put some values. Okay, so for example, for I equals 1 to 9, that means from 1 to 9 with 1 increment. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times it will repeat. So B1 is, this is B1 and the B2, right? So B1, okay, times X I, so I is equals 1, right? And plus B2, so B2 is 157, right? That goes into the y hat variables. I is index. Okay, so first one, when the I goes to 1 and when I goes to 2, 3, 4, 5, 6, 7, 8, 9, then we put the x value. This is the x1 value, right? 49 is x1 value, and x2 is 60, right? X3 is 54, right? So we are going to use these x values, x data, to predict y hat values. Y hat value is predicted value based on the equation what we generated so far. Okay. So we want to plot the trend line as the trend line. The trend line means actually the predicted line, right? We want to express this line on this figure. Hold on means there are some data already plotted here, so we want to overlap our new figures on this figure. Okay, so we want to hold on the previous images and then plot again x. So x, we have variable here x, and y hat. Y hat is a predicted value using these equations, and this one is the prediction. The graph images. The type we showed as a line plot. Okay, this is a middle bar. Okay, middle hyphen. Okay. So retain the current graph in figure, and then we create the line. Okay. This is the trend line. Okay, this is the least square estimation line that can represent the data sets. Alright, the previous one was a very easy one, and this one is a more complicated one. We have trigonometry, and we also have some cosine E right here, and we have a nonlinear equation. This is a highly nonlinear equation, and we have some range of the x value and y values. It's from -5 to 5 and -6 to 6. If we put this value, and what is the answer for z? So we can do the three steps. Okay, so first one is this is a 3D plot, right? This is 3D plot. So first you have to define your grid and the array using the built-in functions. We can say the mesh grid. Okay, and the second step is define your function z equals the function of x and y. So here we have a function of x and y. We can convert it as a MATLAB code. Z equals cosine x. This is dot times cosine y dot times exponential minus square root, things like that. We can express this number here, and use a built-in 3D plot functions. There are 3 different type of functions. There are a number of functions, but usually we can use these 3: surface function, mesh grid function, mesh function, and surface contour function. Okay, let's look at the surf function first. The surf one is the surface functions. So here we have a variable u and variable v, and the u starts with -5 with 0.2 increment to the positive number 5, and the v starts with -6 with 0.2 increment, and this, to the end number should be 6. So let's make a grid, mesh grid u, comma v. They can generate some kind of 2D array that can be used to plot, and this z contains this equation as I explained in the previous previous slide: cosine x and multiply cosine y, exponential, and x and y. So here we have this array using the u and v. So this x and y contains many data, and this data goes into this model, and then the model will generate the variable z at a certain for each of the x and y values. Then we can create a surface plot using x, y, and z data. So x, y was defined as u, v, and z is defined as the predicted value of x, y. Alright, this is the result. This is the result of these equations. Okay, this is the surface, and there is no space. I mean the blank space. This field it's watertight. Is the surface. How about mesh? It's the same thing, but the other part is the different part is mesh. So mesh can generate. Okay, this is mesh images. Surface mesh. Okay, surface contour plot. So this is a little different. This one generates the surface and contour plot on the 2D area. Okay, here you can see surface plot plus contour on the x and y array area. So lastly, I want you to know about there are help functions in MATLAB. So if you don't know which built-in function that you are going to use, or which function is useful for you in certain situation, please go to the product help session, and at the top you can click the help and the product help. Find the appropriate functions. There are thousands of functions registered, so it's very useful for you. So we learned today what is the data types in MATLAB and what is the built-in function in MATLAB, such as we can also use num to string, string to num, or mean, statistics, and square root, any different kind of built-in function we can use, or plot as well. And the third one is we learn how to create 2D and 3D plots in MATLAB. Thank you for watching this long video, and have a great day.